Today,
I'm so sorry.
we're going to start taking a look at derivatives of trig functions. Okay? To do that, the first thing we want to do is just graph sine. Okay? So what does the graph of our sine function look like? If I wanted to graph one period of sine,
Oh, a bunch of
It's a
waves.
wave.
The x-axis is wavy.
It's wavy.
That's
Up,
cosine.
down,
No, cosine. Oh, cosine is the steep one.
yeah, so where does sine start? If I wanted
It starts at -1.
So sine starts, if we're thinking about where it intersects the y-axis, it starts at 0, 0. So then, one full period of sine, let's see if is 2 pi, right? So then we split up the interval between 0 and 2 pi, and we just look at some key values, right? Pi over 2, pi, and 3 pi over 2. So what is sine equal to at pi over 2? 1. What is sine equal to at pi? 0. At pi, 3 pi over 2? Negative, oops, negative 1. And at 2 pi? 0. Right? So our graph looks something like this, right? And we know it keeps going forever in both directions, but we'll just look at one period of sine here. Alright, so this is we're going to say this is my original function, f of x equals sine of x. Now, what I want to do is think about graphing its derivative. Alright, so over here, let's say f prime of x, and we want to figure out what this is going to look like. So, actually, let me do it underneath instead of the side.
You never draw these three. Oh, that's good.
Okay, so what we want to do, and this is just what we talked about a couple of weeks ago. We want to kind of approximate what the derivative is going to look like, sketch out what the derivative might look like. So to do that, we're picking out some key values, right? And we'll just use these same values that we used, right? Pi over 2, pi, 3 pi over 2.
Is this what we have to have it memorized?
Well, partly, but it's more because on the AP test, right, they'll just ask you questions like, what is the derivative of sine at pi over 3? So you'll see what the derivative of sine is equal to here in a second, and you'll just have to think, okay, I'm on the unit circle at pi over 3. This is what that value is. I mean, there's no formula sheet on the AP test, right? So you just gotta have this stuff memorized. So let's look at some of these values. So first, we said when we're graphing a derivative, the first thing we look for is what?
Oh,
Tangent.
Yeah, horizontal tangents, right, where the slope is equal to 0. So if I'm looking at this graph, where would the slope be equal to 0?
pi over 2, 3 pi over 2.
Right, so I know on my derivative, at those values, the derivative will be equal to 0. Okay? Now, we want to look at a couple of other key values here. And so let's just add 0 here. And I guess I didn't draw this to scale real well. Alright, but at 0, what could we maybe approximate that slope to be?
1.
Looks like maybe about 1. Right? So that means the derivative, the value, would be equal to 1. How about at pi? What's the approximate slope there, maybe? Looks like maybe negative 1. Right? How about at 2 pi? Maybe positive 1 again, right? So if I connect these dots, what's that graph?
Cosine.
That is cosine. The derivative of sine is cosine.
Really easy.
Okay?
Oh,
The derivative of sine is just equal to cosine.
That's so
All right.
cool.
Alright, so
hard enough today.
So like, what about the say what's the derivative of sine pi over 3? You just do the cosine of it?
exactly,
Okay.
exactly.
Wait.
What's the derivative of cosine? What?
State the phrase again.
Okay, so that question that I asked earlier, where you were like, "Oh my gosh, my head's exploding," I said if, or something on the AP test could say, "What's the derivative of sine at pi over 3?" Right? Well, we just found that the derivative of sine is cosine. So if I ask that question, "What's the derivative of sine at pi over 3?" You're just finding the cosine of pi over 3, which you should have memorized on the unit source, right? Yeah. So we are going to start making our list here of our derivatives. So if f of x equals sine, f prime of x is just equal to cosine. Okay? So let's do the same thing for cosine now. Okay? Let's graph cosine, which we actually already have, and try to determine its derivative. So for our next step, I'm just going to make this my original function. Okay, we'll say f of x is cosine since we already have it graphed here. And then up here, we'll sketch out its derivative. Okay? So, we just want to look at some approximate values. So well, first we want to look for where the slope is 0. Right? So what values do we have a slope of 0?
0.
At 0.
5.
Pi. And 2 pi. Right? So I know that my derivative is going to cross the x-axis at those 3 values. So then let's look at a couple of other key values. So at pi over 2, the slope is approximately -1. Right? So we'll go to -1 here. And then what about at 3 pi over 2? Maybe approximately +1. So if I connect these dots, what does that look like? Exactly. The derivative of cosine is negative sine.
This is
So if our original function is cosine, its derivative is negative sine.
then like is the derivative of tangent just negative sine?
Not quite. The rest of them are a little bit trickier. Alright? So the tangent, we can derive now. So, yeah, I want to show you how to derive tangent. So, how can I write tangent in terms of sine and cosine? Since we know the derivatives of sine and cosine now, how can I write tangent in terms of sine and cosine?
Sine over cosine.
Exactly. So I'm going to say my original function is tangent, and we're going to redefine that to be sine over cosine. Now, if I wanted to take the derivative of something like that, of a quotient of 2 other functions, how do I do that? Quotient rule, right? So I can take the derivative of tangent using the quotient rule, right? And we know what the derivatives of sine and cosine will be. So my derivative here, so how do I use the quotient rule?
It's
G is the cosine times negative sine, or cosine times cosine.
Yeah, so cosine, so the g times f prime, so f prime is cosine.
Isn't there like a rule where it's like cosine 2 of x equals something equals like sine or something? Like sine plus 1.
We're gonna
Yeah, well, we're going to use that here in a second.
Okay.
Okay, so now, so we've got g times f prime minus the top.
negative sine.
Yeah, so sine times negative sine, right? over what? Over cosine squared. So now let's simplify this. So cosine squared.
Dang
Did you start a stupid counter for another class?
For one student.
Oh.
Yeah,
Who?
he requested it.
Was it Mikey?
No, it wasn't Mikey. It was Wayne.
Of course.
Why is our truck on the curb? They just like pulled up right onto the curb. They're not in the right lane.
Why not?
Oh wait, yeah, they're on the right. No, they're not.
Alright, so
Yeah,
then we'll have minus a negative. So we'll have a double negative here.
No,
Alright, so positive sine times sine, which would be sine squared.
Oh, that equals 1.
Yeah.
There we go. Yep. So cosine squared plus sine squared is just
So we did learn something in the previous year.
1. So
And
this
then-
is 1 over cosine squared.
Would that be the
I
That would be
forget
the-
what that one is.
that would
I
be
think
the
I heard it.
It's secant
Secant
Secant squared.
Dang it.
I
was gonna get that.
So the derivative of tangent is secant squared.
So we just did all the work just to find out it was just secant squared.
Yeah,
So now I just have that memorized.
exactly.
I gotta go over to Mr. Miller and get one of those
Yes.
circles. I lost mine.
I only
I'm pretty sure it's in the trash somewhere.
You probably got really mad at it and threw it away.
Alright, so
Thought I was done with math.
these trig derivatives, okay, I mean, you're never going to have to do this again because you know now that the derivative of tangent is just secant squared. Okay, I mean, if you forget that, you can derive it like this, but I want you to memorize these. Okay, I don't want you to go through that process. So we've got derivative of sine is cosine, derivative of cosine is negative sine, and the derivative of tangent is secant squared. We could derive the rest of them in a similar fashion, but we're just going to memorize them. All right, so the other three, secant, cosecant, and cotangent, their derivatives look like this. So the derivative of secant is just secant times tangent. The derivative of cosecant is negative cosecant cotangent. And the derivative of cotangent is negative cosecant squared.
I'm gonna write all this.
What did you say? Oh, I thought you said you were going to throw up.
That too. Don't mess with me.
Okay, so these are our 6 trig derivatives. This is another thing that we just need to memorize. Okay, and
I don't have
it
enough
will.
room in
Okay,
my
because we're going to work with these a lot. All right, so you're going to have plenty of practice working with these, finding derivatives. All right, so these need to be memorized. I mean, you guys already have the quotient rule pretty much down, right? And when I wrote that on the board, you guys growled and said, "Oh my gosh, we're never going to memorize that," but pretty much already have it memorized. All right. So this is another set of information that we do need to memorize. Okay, these 6 trig derivatives. So let's practice finding some derivatives using trig functions here. I'll just. I don't care anyway. You still have to do it.
Well, then she doesn't have to.
If she wants to pass, she does.
I swear to God.
Alright, so let's say our original function is 1 over x squared plus cosine of x minus 2 tangent of x.
Wait, what are we doing?
Oh, God.
We want to take the derivative.
Oh,
Take me to the jail. That's good too.
Okay? So, first we want to rewrite this, right? How can I rewrite 1 over x squared before I take the derivative?
To x negative. I can't.
X to the negative second power,
Thank you.
right? So before I take the derivative, I just want to rewrite this as x to the negative second plus cosine of x minus 2 tangent of x. Now, since I'm adding and subtracting everything here, I'm just taking the derivative of each individual piece, right? There's no product rule, no quotient rule, nothing like that. So this first piece, I'm just using the power rule. And then for my trig functions, I'm using the derivatives that we just found. So the derivative of cosine, we know is negative sine. The derivative of tangent is secant squared, so this would just be minus 2 secant squared. That's all. There has to be a catch. Are you okay with something like that? Alright.
I'm still coughing all that down.
Okay, I'll just do another one beneath. Alright. Alright, how about this? How about x squared times sine of x? Okay, so here I'm multiplying. I'm multiplying this function times this function. Whenever we're multiplying two things together, what do we have to do to find the derivative? Product.
I'm more nervous about it because I can't remember half of it. Okay.
Product rule is the easier one. Quotient rule is the one that's kind of tricky to read.
I can remember the quotient rule, but the product is like
It's the. Yeah, I think you're right.
So 2x
2x
sine
9 plus x squared.
Do we have to like distribute them?
No. So in this case, I mean, there isn't any distribution you can do.
I forget the
So the product rule is derivative of the first times the second plus the first times the derivative of the second. Right? F prime g plus f g prime.
I'm just looking at the, I understand that.
The first one or second one?
Second one.
So this is my first function.
Yeah.
My hair is
This is my second function. Right?
Yeah.
So down here, we're saying this is f and g. This is f prime times g plus f g prime.
Okay. I thought we were just doing the g of x. I didn't know where. Yeah. Okay.
Okay, we okay with something like that? All right. How about let's see. About cotangent minus tangent plus, I don't know, 4x.
Ah, is there anything we can do?
Make it look a little nicer.
Yeah.
Really,
Isn't there cosecant plus secant squared?
But it has to be, it has to have one.
I don't know. I don't think so.
So, I mean, you could turn this 4 into 1 plus 3, and then use one of those properties. But we don't need to. We can just leave it like that.
Wait, a question.
What's up?
Since it's minus tangent,
Mhm.
whenever you. No, never mind. I just did it that way. Why would it stop talking? Well, okay, for whatever reason, I thought that it was. Yeah, I got that. I put it like as negative secant squared, so I made it a positive instead, but it's not.
Yeah. Derivative of tangent is just positive secant squared. how about one like this? X squared over 3x squared over cosine of x. So there's a couple options here. I want to see what option you guys choose. So, I mean, the obvious choice is use quotient rule, right? And I mean, that's perfectly fine. That will get you a correct answer. There is another option that we'll take a look at after you finish it up here. Well, not for quotient. Remember, quotient rule is square the denominator. I mean, you told me the quotient rule earlier. Yeah.
Can you, I don't know, make this look like. Is that scary? It's not scary, but. No, it's just that.
Yeah.
I was thinking
Oh,
Alright, I guess I'll just solve the quotient rule version.
Is this even working? Not even gonna say
No. Hey, my boss said no.
she said it.
She said it.
She didn't realize. See, you don't realize what you say.
Alright, so did we get something that looked like this using the quotient rule?
Yep.
Okay. Another option. Okay, and this will come in handy on some problems. This one, it might not make it much easier, but on some problems it will make it a lot easier. 1 over cosine is equal to what? Secant. I could rewrite this original problem as 3x squared times secant of x and take that derivative. We would still have to use product rule, right? But we would be avoiding quotient rule then, right? So with that in mind, if I give you something like this, g of x equals 1 over tangent of x. I mean, your first thought would be, oh, I have to use quotient rule to find this derivative, right? But how could, before taking the derivative, how could I rewrite this to make finding the derivative much simpler? So 1 over tangent is just cotangent, right? So what's the derivative of cotangent?
Negative cosecant.
So the derivative of 1 over tangent is also negative cosecant squared, because 1 over tangent and cotangent are equal. Okay, so using reciprocal properties before taking a derivative will probably come in handy. Okay? And remember, you can do that with any function. You can do algebra on any function, okay, before taking the derivative to try to make taking the derivative a little bit easier. Okay. Any questions on trig derivatives so far? There is a math excel.
Do you think we're actually going to pass